Okay, so before we get started, I'm going to ask you a simple question. I've got two objects on the screen. Obviously, one is a circle, and the other one is supposed to be a line, but for some reason my program won't put the other arrowhead on it, but we'll pretend it's a line. And I'm asking a simple question. I'm going to move that green line around and have it intersect the circle. Okay, so obviously this is scenario one. 0 points of intersection. Okay, not very exciting. What do you call it when it has 1 point of intersection? Tangent, very good. So if I take this bad boy and I slide it over here and it hits in just 1 point, that is a tangent. How many different points can you have? In other words, how many different places can that line intersect the circle? One. No. Zero. Infinite, right. There are infinitely many points that line can interact with if it only intersects one. And then the other scenario is that if we take this and we slide it that way, it becomes what kind of line? No. Chords or segments? Secant line, very good. So far we've looked at 0 points of intersection, not very exciting. 1 point of intersection, 2 points of intersection. How do I get 3? Oh, excellent suggestion. So there is a hypothesis presented that would be 3 points of intersection. However, that is wrong. Why? Riku. Beautiful. The center is not part of the circle. So therefore, if we extend a diameter, which remember a diameter is also a chord, so if we extend the diameter to be a line, it's still a secant line. It's still only intersecting the circle in 2 points. So again, we'll come back to my question. How do I get it to intersect in 3 points? Curve. Can you curve a line? No. Therefore, impossible. See. We're all good on that, yes? Okay. So then, what if we change the problem? What if instead of a line, we do something crazy like a parabola? Okay, so let's use that. And I'm not going to move it because I don't want to help you, but how many different ways can that parabola intersect the circle? So obviously I'll give you one. It doesn't. Can that parabola intersect the circle in only 1 point?
No.
Yeah.
Yes or no? Riku?
Oh, that's the vertex game.
Clarify what you were saying.
Yeah.
I don't understand.
So I've got a parabola. I've got a parabola in green, and I've got a circle. Can I have that parabola intersect the circle in exactly 1 point?
From where it is right now.
No.
Well, you have to move it.
No.
So, no?
No.
Yes.
Yes.
I made it yes.
Yeah.
I made it no.
How many don't know?
How many are confused and don't want to vote because they're afraid their peers will judge them? Okay. You were jumping on board with that? Okay. Okay? We're good. Yes? 1. Can I do 2? Shut up. Yes? How?
You put it more in the circle.
Bring it down a little bit. Let's get this mess out of the way. Okay? Good? Can I do 3?
Yes.
How?
Yes.
Move it down.
Bring it down more?
Bring it down to the bottom of the circle.
Oh.
can do 1, you can do 3.
Even when you get to 3. You never go.
Close enough? Can I do 4?
Yeah.
How?
Bring it out more.
Can I do 5?
No.
I said,
No? How many think yes? How many think no? How many have no clue? Excellent. It's no. That's it. Okay. All right. Any problems so far? Excellent. So let's get rid of this. And before we dive into what we're going to do today, I want to make sure that we're all on the same page. Simplify that, please.
Oh yeah, x squared. X squared plus 6x plus 9. 100% that I might have 1,000. Why is it? Because it's x times 3, and then it's x times 3 again. So it's 6x.
First, inside,
Yeah,
outside.
put the like x
And how many people? First.
plus 6x times.
Jenna, what's it equal?
x squared plus 6x plus 9.
Perfect. Let's give it up. It does not equal x squared plus 9. Whoops, I did it wrong. I don't know where that other x came from. I got a little excited. Sorry. It does not equal x squared plus 9. You can do that however you want. One of the ways you can do it is write it as x plus 3 times x plus 3 and multiply it out, FOIL it out. You could use the method that I've shown you in the past. Square the first term, multiply 2 together, double it, square the last term. I don't care how you do it, but you must be able to do that or you will crash and burn from this point on. We've done this ad nauseum, so we're not going to do this again. This is your last time. The rest of this falls on you. And it doesn't matter if there's a minus sign in there. It doesn't matter if there's a number in front of the x. It follows the same procedure. So pick a method and run with it, but you have to be able to multiply that out. Questions? Hot diggity. Okay. So let's go on to the next thing.
Wait, I can do like this. Okay, but I'm serious. I need it for the show.
We're going to talk about circles. I don't understand why you think that it's just okay to carry on your conversation when I'm trying to do my job. We're going to talk about circles, and we're going to start slow and we're going to ramp this up. First things we're going to do, and I honestly don't know, did you do circles in Algebra 1? I got some no's and some yeses. Okay, so I'll assume that you didn't, and we'll move on from there. Okay? General form of a coordinate circle is that. Okay. X minus h quantity squared plus y minus k quantity squared, that's a k, equals r squared. hk is the center. And obviously, r is the radius. So if I said to you, Jack, hey, Jack, I would like you to graph a circle. You would need two punks. I got one here and one here. You would need 2 pieces of information from me. What would they be?
Or like the center and just
Perfect. Where is it located? i.e. the center, how big is it? And those two chunks of information get you what you need. The center is where it's located, the radius is how big it is. We good?
Yes.
Good. So what's the equation of the red circle? Where's the center?
0, 0.
Also known as the origin. Very good. What's the radius? Okay, so I'll ask my question again. What's the equation of the red circle? Say it loud, say it proud.
X minus 0
Uh-huh.
squared plus y minus 0 squared equals 4 squared.
Equals what?
4 squared.
Which is, we're all big people
16,
here.
16.
16, very good. Okay. Do I need the minus zeros? No. Is it wrong to put them in there?
No.
No. If you want to come off the porch and run with the big dogs, you can do it that way. Now, let's talk about common mistakes when working with circles. Number one, people plug in for the x and y instead of the h and k. You need two variables. Those are the x and y's. They stay there. The other common mistake is they forget to square the r. So they would have x squared plus y squared equals 4 instead of 16. Okay, you have 30 seconds. Write the equation of the green triangle, or that's a circle really. The equation of the green circle. You may have to look at the screens to count. And 28, 29, 30. L, what's the equation of that green circle?
X minus 6 squared plus y minus 5 squared equals 9.
Hold on, I can't write that fast. Y minus,
5 squared equals 9.
how'd she do? We're good? Excellent. Okay. Easy peasy. All right, let's go back to the red circle. What's the x-intercepts, plural, of that red circle? 4, negative 4. What are the y-intercepts of that red circle? 4, negative 4. Okay. X equals 4, x equals negative 4. Y equals 4, y equals negative 4. What are the x-intercepts of the green circle? There is none. What are the y-intercepts of the green circle? There is none. Okay, so let's talk about that a little bit. Let's suppose you didn't have a picture sitting in front of you, and I just gave you this equation, x squared plus y squared equals 16, and I asked you to find the x-intercepts. Okay, so we know by now that the x-intercept is the point where it crosses the x-axis. What's true about every point on this x-axis? Is that a hand raise? Or are you just flexing? Just flexing? Okay. What's true about every point on the x-axis?
The y value is the same.
100% correct. What is that value?
0.
Perfect. And you know this, you're just bashful. Every point on that axis, the y value is 0, all the x values are different. So therefore, if I plug 0 into this equation for y, I get x squared equals 16, so therefore x equals, plus or minus 4. Which is what we already knew. Same thing with the y-intercepts. The y-intercepts are where x equals 0. So you might want, if you're struggling with that, you might want to write that down. X-intercepts are found by plugging 0 in for y. Y-intercepts are found by plugging 0 in for x. And I think it's only appropriate that we take a look at this circle. I know what my answer is going to be. But algebraically, I want to show you what happens and why we get an answer that doesn't make any sense. Okay? So let's do the x-intercept. X-intercepts happen when y is equal to 0. So I'm going to plug 0 in for y. And I get x minus 6 quantity squared plus negative 5 quantity squared equals 9. My 9 got a little funky there. X minus 6 quantity squared is equal to negative 5 squared is 25. Move that to the other side is 16. Is negative 16. Missing my parentheses there. What's my next step in solving that problem?
Square root.
Take the square root. Why is that going to be a big deal? What's wrong?
It's a negative.
It's a negative. And because in this class we only deal with real numbers, or the real number set, a negative square root doesn't work for us. Next year in advanced algebra that will change, but this is an advanced algebra, so we're not going to worry about it. Therefore, there's no solution to that equation, which translates to the circle not intersecting the x and y axis. Now, another thing that might prove helpful is, again, if you don't have the picture, notice where our center is located. Based on what L told us, the center is at 6, 5. The radius, however, is 3. Notice that the radius is smaller than both the x and the y values. That will be an indicator that the circle isn't going to reach the axes. So you have no x and y intercepts. Okay? Getting back to what we discussed before, if you consider the axes to be lines, which they are, that will help you determine your possible answers. It could be no intercepts, it could be 1, the circle could be sitting on the axes, or it could be 2. Most commonly, it's going to be 2 or none. Are we good? Okay. How could we make this more interesting? Full disclosure, what I find interesting, you will find horrific. So, how could we make this problem more challenging, or this idea more challenging? What if instead of an axis, we just made it a plain old line? That we did already. Okay, so let's, without drawing the picture, let's talk about this. First of all, where's the center of the circle? Say again? No? 2, negative 3. What's the radius? 7. Will we have x and y intercepts?
Yes.
Yes, because the radius is bigger than both of the x and y coordinates. So we would get probably 2 x intercepts and probably 2 y intercepts. And we can go through and do that math again, but we already did it. Okay. Let's make it more interesting. We did that one already. This is what we want to talk about here. Okay. So we're going to do some algebra first, and then we're going to ramp it up a little bit. Okay. So we'll do the red one first. I've got this point P, and it intersects the circle with a an x value of 2. What's the y value? Okay, so take 2 seconds and visualize what I'm asking you. I've got a circle. What can you tell me about that circle, by the way? Where's the center? -1, 2, and the radius is 5. Beautiful. Okay. And then I've got an x value of 2. And I want to know what the y values are if P is on the circle. So what you're visualizing right now is a circle with a point on the circle. I'm going to challenge you to visualize it differently. I want a line that has all the x values of 2. What does that line look like? You're changing your mind? What's the line look like that has all the x values of 2, but any possible y value? Right. It's a vertical line. Beautiful. So this is the next evolution. Instead of looking for where the circle intercepts the x and y axes, now we want to intersect that circle with a vertical line. And then you're all fairly bright. What is the blue going to do? Horizontal line. So we'll do the red one first. Now I can make it more complicated than I needed to, but it's really simple. What do I do with that 2? Plug it in. For the first time through, I purposely picked a nice number. It's a nice number because this second term will disappear. Two ways to solve that problem. You've done it in the past, so I'm not going to hype on this, but you could take the square root of both sides, or you could multiply out the left side. Because I've isolated the squared term, I would use the square root method. But again, this is a quadratic. Quadratics always, without exceptions, have 2 answers. So therefore, x is equal to -1 plus or minus 5, which would be x is equal to -6 or 4. Okay? Questions? So there's 2 parts to this. One is the geometry part, or the graphing part, visualizing what's going on here. Instead of using the vertical axis, also known as the y-axis, I'm taking a different vertical line, which is x equals 2, and I'm figuring out where that intersects the circle. In the blue, with Q, we're doing the same thing, except we're running a horizontal line through the circle. Okay, solve for Q. This one's on you. Oh my God, I screwed up that problem. Why did you wait till I got to the end? It's a good thing I recorded this, by the way. I can go back and see where I screwed up. Paige, say that again, please. It's a great question. I screwed up. How many of you noticed that? Why didn't you say something, knuckleheads? If you didn't notice, you're off the hook. That's okay. I still love you.
You wrote it.
Wow. That's better. Okay, now solve the blue one and don't screw up like I did. Just to be clear, what are you plugging the -3 in for? Good, at least somebody's paying attention. Lindsay, that's sick. She dying or something? You know what she had? She's got influenza A. That's okay. It's going around. They'll probably kill me if I get it.
I had that in
It's horrible.
Actually, it only lasted
Yeah, that's a long time. If you were, okay, so if we were in school, I know you're still school, but if we were in school, how many days is school?
What is your square?
You're not gonna do that.
Yeah.
No, 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 no. Elbows up.
For the cancel. The zeros and zeros.
And ours here.
I got X and is there supposed to be two values? No. Plus or minus zeros.
All right, without going through all of this, what is the x value of the point Q?
-1.
Just one answer?
Yeah.
We all agree it's only one answer? Really? Why?
Because it comes out to 0.
Okay, so if there is, I'll accept that answer, that x is equal to only -1, there's only one answer of that quadratic, or again, you can go back, it's the same answer twice. What does that look like if I was to graph all of this? How many times does the circle hit the horizontal line of -3? Just one time, right? It's tangent to that horizontal line. So that is possible. How we doing for time? Beautiful. Okay. Now, we've been nice in that we've intersected a circle with a horizontal line, the x-axis. We've intersected a circle with a horizontal line that's not the x-axis. We've intersected a circle with a vertical line that's the y-axis, and now some old random vertical line. And now we can make it more interesting by let's remove the restrictions of the line and just create some old crazy line. There's a picture. First time through, I'll give you a picture. You'll notice from the picture that I'm probably not going to get a very pretty answer. My points of intersection are here and here, but what I do know is that if I do it correctly, I should get two answers. I also notice from the picture that one answer is in quadrant 2, which means the x value should be negative and the y value should be positive. And one of them is in quadrant 3 where they're both negative. That having been said, how would you attack this problem? Let's go back. How did we attack these problems? Plugged it in. So I'll ask my question again. How would we attack this problem? Jack?
On the y-intercept?
Not necessarily the y-intercept, but could you expound upon what you mean by that? No? For the rest of you, some of you shouted out plug it in. Could you be specific? Eva?
It would be 2x plus 3 plus 1 squared. Like, that's how you
Yep. Take this puppy, plug it in right there. Okay, now before I start attacking this, let me be clear. Or let me ask you a question. Do you know how to square a trinomial? Because notice that second term is now a trinomial. Do you know how to square that? The answer is no. And the answer is also, you're not going to do that. What obvious thing am I missing?
You can add them together.
3 plus 1 is 4. Okay? However, in the past, I've had a ton of people try to literally write out 2x plus 3 plus 1 times 2x plus 3 plus 1 and multiply all of that out, when in fact all you need to do is just add those two. Okay, we're doing okay so far. Now what do you do? Now, you might suggest, oh, take the square root of both sides. No. Okay, that doesn't work. It only works when you isolate it into one square root term. So now what do I do? That doesn't work. Any other ideas? Explain.
like, it would be x plus 1.
I'm sorry, it would be what?
Sorry, never mind.
It would be what? Oh, I'm not letting you off the hook here. What is this?
X squared plus
X squared plus 1x plus 1?
No. Now you're just shouting out numbers. What is x plus 1 quantity squared, Jack?
X squared plus 2x plus 1.
Okay, that was the easy one. What is 2x plus 4 quantity squared? Ben.
It's 2x squared plus 15.
Holy guacamole.
Oh, it's 4x.
Riku, what's 2x plus 4 quantity squared?
I didn't solve this.
Tell me now.
4x squared
That's a good start, I'll give you that. Uh-huh.
plus 8x. Oh, plus
Oh, I like that better.
plus 6.
Beautiful. Now what? Add it all, combine like terms. Turn it into something pretty.
I knew those we have our sheet.
So you can make your life difficult, or you can make your life easy. I prefer easy, and I think you would all agree with that. So then I pick up my handy dandy calculator, and there's a reason why we spent a week writing calculator programs. I would use my calculator to figure out what x is equal to. And when you do that, you would share that with your teacher who's writing on the board and tell me that x is equal to
-0.52.
and negative 3.08. Okay, so before I ask the rest of you if he's right or wrong, let me ask you a simple question. Does that jive with my picture? According to my picture, both of my x values should be negative. Oh, look, they're both negative. Here's my 0.52 over here. Here's my negative 3.08. Well done. We're almost completed. We're almost completed. We're almost done. How do I find the y values? Where would you plug it in? Think carefully before you answer. Into the line, not into the quadratic circle. You don't want to do that again. Just plug it into the line. I do understand that at this point you're going to have to use an approximation because the program that we wrote, we didn't go deep enough to have it store the numbers. We can, but we don't have to. Okay. We can go back to programming and you could figure out how to adjust your program to have it take the answers and store them into values. We're not going to bother. We're just going to take negative 0.52 and plug it into the equation of the line to find the values. When you're giving your answers, however, and this is important, you want your answers in the form of a point because you have to pair the y's up with the correct x's. And what are those y's? Yeah?
1.96.
Is for negative 0.52?
Yes.
1.96 you said?
Yes.
Okay. And?
Negative 3.6.
Negative 3.6. 16, 1/6. Love it. This process is no different than what we did when we found the intersection of two lines. At some point in the process of solving for the intersection of two lines, you plug one into the other. Now, maybe you set them equal to each other. Maybe you did it, yeah, but there's still the same idea. You're plugging one into the other and getting an answer. The same is true here. You're taking the equation of the line, plugging it into the circle. Okay. Do you need the graph? No. Should you bother drawing the graph? That's entirely up to you. Some people are going to want the graph to have an idea of where they're working towards. Am I going to get 2 answers? Am I going to get no answers? So what's it going to look like when I get no answers? Well, we've seen quadratics already. Let's go down to this quadratic. We've seen a number of quadratics like this, where when you plug it into your calculator, it says error. Right? It is possible to do all that work and you get your quadratic that gives you an error. That just simply means that the circle doesn't intersect the line, or the line doesn't intersect the circle. Or you might get only one answer. What does that mean? It means it's tangent. It only hits in one spot. Because remember, you could do 0, 1, or 2. Most commonly, we're going to end up with this scenario where there's 2 solutions. All right. So, questions on the concept of what we're doing. Questions on the application of solving the problem. And so now you understand what I said at the beginning of the period. If you can't square a binomial, you're going to have problems. If you can't square a binomial, then this is completely irrelevant, and you need to practice this and this being squared. And again, use the method that I use, or write it out as 2x plus 4 times 2x plus 4 in FOIL. Questions? We're good? Okay. So this is going to ramp up. It starts very slow with x and y intercepts, like we talked about. 0 in for x, 0 in for y. Then the next step up is the vertical and horizontal lines. Plug in whatever value for x, plug in whatever value for y. And then the third one is the nastiness of a line with a circle. Where do we go to from here? Not today, but where could we go to from here? We have 2 options. What else have we talked about today? Yeah, we could intersect a parabola with a circle. That'd be fun. Right? So what would that look like? That would look like something like, we'll do it in vibrant green because it's a little scary. We could do something like that. Oh, and I just heard somebody say it. 2 circles? We could also do 2 circles. Huh. How many ways could 2 circles intersect? Well, 0 was obvious. Can they do 1?
Yes.
Yes.
Yeah, they're like a snowman. Can you do 2?
Yes.
Yeah. Could you do 3?
Yeah.
You think so?
Yeah.
Okay. Draw on your paper what 2 circles intersecting and hitting at 3 points looks like.
Look, 3 I needed 3. That works. That's still 1. That's still nice.
1, 2, 3.